Alright, good morning. How is everyone today? Good. Awesome. Alright, any questions? This is a really good time to ask questions about homework 4. Alright, well, let's go through ODP 413. So this was this function that's supposed to take a string, count the number of e's in that string, and then return that as an integer. And we went through, the basic setup for this yesterday, using a for loop and string length, or looking for the null terminator, or things like that. So here's one solution to this. It's not a lot of code, right? One of the challenging / frustrating things about things like this is that there's not a lot of code. It's not like if you keep writing code, eventually you'll get the right answer, right? It's very few lines, but those lines have to be just right. They've got to do exactly the right thing, and they can't do any harm along the way. And that can be challenging, right? A lot of things, you try to build a structure to hold something up, and sometimes you just keep adding more wooden nails and more wooden nails and some glue and some concrete, and eventually you'll get something that will hold up, your bird bath or whatever you're building. That's not how code works, right? It's trying to find exactly which wood and which nails and how they should be placed next to one another. So let's take this function apart a little bit and see what's going on with it. Hold on one sec. All right, so we usually include standardIO.h in a main program. The only time you need standardIO.h is if you're doing input-output, so printf, fgets, scanf, things like that. That's why we include standardIO. That's to prototype these functions. So if you're using functions that you haven't written and you're not putting the code for inside your main program, you probably need an include file. Now, if you accidentally include standardIO and you don't need it, it doesn't usually do any harm, okay? But I'm not going to say always include standardIO.h. Really, you don't want to include it unless you're trying to do standard input or output operations. However, I am using this function string length to find how many characters were in this string that was passed to this function. So I'm including string.h, okay? And if you look at the man page on string length, right, it will tell you right in the synopsis, include string.h. And then it tells you the prototype for this string length function takes a pointer to a character, and it returns, well, it says size under t, but if you dig through it, it's basically an integer. And yeah, so somebody just commented, they usually include standardIO so they can make debug print statements. If you write code and it's not working, a really, really good first order way to deal with that is to add in some print statements. See what the values of variables are. Write a print statement when you start a loop. Write a print statement when you're done with the loop. Print out everything, and there's a good chance you'll figure out what's going on. So if this code was not working, what would I do? I would put a statement in the very beginning, and I would say, let's print out the value of arg. I'd say print, county has been called, argument equals angle bracket %s close angle bracket, and I print out ARG for that %s. And then I would say entering for loop. And then inside the for loop, right at the very top, right before this, I would print out inside for loop, comma, I equals, and print out the value of I. And then I would probably go ahead and print out arg bracket I equals and print out the value of arg bracket I as a %c inside angle brackets. And then this if statement, I would add some curly brackets here, and if arg I is equal to e, I would print out, if statement is true, new value of c is, and I'd print out the value of c after I do the increment. And then when I'm done with my for loop, I would put a statement saying, done with for loop, about to return, value I'm returning is, and print out the value of c. Okay? Now you've got enough, you run your program, and if it's not doing the right thing, you can see exactly what happened at every point throughout your program. Let's see, wouldn't it be better to assign the value of string length to a variable rather than call it for each iteration of the for loop? So that's a different issue, but this is a good question. In this for loop, I'm calling this string length function again and again. Time-wise, that's fairly expensive. Function calls take a lot of overhead. A good compiler will notice that arg is not changing, and it will call string length once and save that value somewhere in memory, and then just read that from memory. But yeah, it's a really good observation that we are calling this function repeatedly. So you could save it in a variable first, but I don't usually worry about CPU time too much. All right, so if your code's not working, throw in print statements. We'll learn how to use a debugger in a few weeks, and that will be a more powerful tool in our arsenal, but print statements will work. All right, so I'm including string.h. Here's my declaration of the function. This is just like the prototype from the README, right? Except the prototype doesn't have to name the variable. When you prototype a function, all you need to specify is the name of the function, the type of thing it returns, and the type of each argument. And if you put a name in here for the prototype, it's ignored. But when you actually write the function, right, not prototyping it, but when you're actually writing the code for the function, and this statement here is the beginning of that function, I need to name my variables so that I have a way to access them inside the code. All right, so I'm calling my variable arg. You can call it anything you want. Initialize your counter, and always make sure you initialize things that you want to have the value 0. Set it equal to 0. And this is a tricky point, because some compilers will automatically initialize variables to 0. Some operating systems will automatically have initialization to 0 when you write a C program. Some systems don't, okay? There's no standard that says if I don't initialize C, it's going to be 0. But if you get in the habit of not initializing, and you're on a system where it lets you get away with that, it's going to be a really hard habit to change when you get to a different system where uninitialized variables have random values. All right, so make sure you always initialize. More modern languages will actually yell at you if you don't initialize variables. All right, so C is my running counter, and then here's my for loop. So we went through this yesterday, right? I'm going to run from 0 up through string length -1. Okay. And then inside, I'm going to look at the ith argument of this array, the ith element, which is character I in my input string, and see if it's equal to equal signs to an E. And if it is, I'm going to increment my counter. And then when I exit, I'm just going to return whatever the value of that counter was. All right, so another thing that I've seen is people not indenting code. Let's say you write your code like this. All right, this will compile. It'll compile just fine. The compiler doesn't care about indenting your code. The reason we indent our code, and for the ODP, it doesn't look at your indenting, right? You don't lose points for having code that's not indented. But the reason we indent code is because it helps us look at our code and know what's going on. All right. If you try to assess this code, you won't get points. You'll end up with 0 out of 10 on each test. Because there's a problem in this code. And the problem may not be obvious, especially, in the middle of the night if you've been doing this for a few hours. This looks perfectly fine. There's my for loop. If my argument is E, I'm going to increment my counter. I'm going to return the counter at the end, right? And here's what happens is, you write this code. So let's call it test. Don't ever call your program test, by the way. But you write this code and you try to compile it and you get an error. And it says, I expected a declaration or a statement at the end of the input. All right, so you go in and your curly brackets don't match up. So you add an extra curly bracket at the end. And you compile it and it works right now. What the heck did I do? Oh, this is just my function. But here's the problem, right? As someone just pointed out, my return statement is actually inside my for loop, right? Now that's not necessarily obvious from looking at this code. And especially if, you got this by adding extra things and responding to error messages by just adding more curly brackets. And most people do this, right? If you get a compile error and you think it's related to curly brackets, people just start adding curly brackets in. Don't do that, okay? That's like, I'm lost, I'm going to turn here, right? It might take you to the right place, but chances are it's just going to get you more lost. So how do we deal with curly brackets? Indent your code, okay? So if you indent everything, right? So the way I write code, and you can find your own style, but the only things I have in column 1 are things that are either outside of functions, like my include statement, or the declaration of a function, or the beginning or ending curly bracket of a function. And everything that's inside a function is indented at least one level. Okay? Similarly, inside a loop, I'm going to indent everything. And so the only things that I'm going to find at this first level of indenting are either my variable declarations, my statements that are running, my loops beginning and ending, or, the exit code. And if statements, exactly the same way. I'm going to indent the body of my if statement. So this is going to get indented, and this is going to match the corresponding if statement. And if I had written this with indenting, my code would have looked like this. And this looks very different from what I had a moment ago. Because what's the main execution of my program? There's a declaration. There's a for loop. There's the end of the for loop. So I don't actually have a return statement after my for loop. And in fact, inside the body of my for loop, I have a return statement. So this code will initialize my counter. It will start a for loop. It will check the first character to see if it's equal to E and count that. And then it'll return my count right away. It only looks at the first character, right? And it's fairly easy to see that from looking at this, whereas with everything left justified, that's hard to see. All right, so coding style can help you there, right? Commenting will also help. All right, let's see. Chat comments. Pros and cons of C++ versus ++C. So, you know, C was written, the language C was written a long time ago. CPU cycles were pretty expensive. And so you can do C equals C plus 1. And to a basic compiler, this will say read the value of C out of memory, add 1 to that, right? So take the constant 1, take that and C, send them to the adder, combine them, take the result, put that back into C. On the other hand, doing this or doing this was a little trick that you could use to tell the compiler, hey, I don't need to do an addition, I can do an increment. And probably most CPUs, certainly at the time, had an increment instruction. An increment was faster and cheaper than doing an addition. So instead of having a constant 1 stored somewhere and pulling that out and pulling C and combining them and then storing them back in C, this would code as just, you know, increment C. Alright, now the difference between this and that depends on what you're doing with this. If I'm just incrementing C, makes no difference. Okay, those will both probably assemble into just increment register C, or wherever C is stored. But if you're doing something like I equals this, right, very different behaviors. So this will increment C and then set I equal to that value. So this looks like C equals C plus 1, and then I equals C. This is called a post increment, so this will look like I equals C, and then C equals C plus 1. So they do very different things, and it depends on when you want that increment to happen relative to the value that you're using. And if you're in doubt, split it up. So yeah, what someone already said in chat. If arg bracket I equals E versus if integer arg bracket I equals 101. Let's see. Is that a question? So, all right, so that's a fine thing to do. Right, that's totally legit. That's looking at the ith character of this string arg and comparing it to E. But then this other thing that was written in chat, if integer arg bracket I equals 101, where presumably this is the ASCII code for an E. You can probably get away with that, but it would make me a little nervous, because casting from this to an integer, there may be a standard for that. My concern is that, strictly speaking, this location in memory has bytes before and after it, and if I try to cast this into an integer, my concern would be, would it take the bytes that appear before or after that and include those in the big long integer? And if I was worried about that, I would probably do something like, you know, n equals arg bracket I, and I would end it with a bit mask to throw away those other bits. I suspect the compiler is probably pretty friendly about doing this, but run some test cases and try some negative numbers, because those have upper bits also. Well, that is a negative. But in general, this is preferred because this is ASCII centric, right? And this is more or less guaranteed to work even if you're on a system that's not using ASCII. So if you go back to a machine that's using EBCDIC, right, we don't want to code a particular ASCII code. And if we go forward to a system that's using Unicode, right, then all bets are off for this. All right, cool. Keep going. Other questions? So some comments that I've been telling people in email, right? The ODPs, numerically small part of your grade, okay? The goal of the ODPs is to help you learn these concepts, right? So you've seen, you know, functions in 121, but maybe you were rusty with them, maybe you don't have a lot of experience, right? Here's a chance to call functions, pass things back from functions. It's really important that you nail down these ODPs. Even if, you know, the ODP has closed and you can't get points for it, if you're not totally clear absolutely on how to do these past ODPs, get clear, okay? Work on them, ask me questions, come to office hours. Office hours are probably the best way to work with me on this stuff. Email, not so good, right? A lot of back and forth, a lot of time in between. That's hard to do. Catch me in office hours. You can screen share, you can show me your code, you can run your test cases, show me exactly what's happening. I can ask you questions or suggest things to try that will hopefully help you, you know, see better what's going on and figure this stuff out. So take advantage of that, and don't worry if the ODP is already done or if the homework assignment is already done, right? Our goal is by the end of the course, you know, you're very proficient in C, so that in CSE222 we can use C to talk about data structures and build complex programs using data structures without having to struggle with the C itself. So that's a long-term goal. All right, put in print statements for debugging. We talked about that. Yeah, that's it for general advice. All right, homework 4. This is a really good time to ask questions because I'm here and we've got time. So if there's anything remaining on homework 4, the stick program that you're not sure on, this would be a good time to ask. All right, Friday's class I may cut short a little bit. I'm supposed to be in a meeting at 11:30. I've told them I have class till 11:50, but I might cut out about 10 minutes early tomorrow. But we didn't have an earthquake drill in this section today because I was in the first morning section. So that'll work out time-wise. So we might end about 11:40 tomorrow. All right. Let me just make a general comment on functions in C. So here's our main program, and here's, well, let me just do this in an editor. Alright, so let's say I want to write a function that will square a number. Right, it's going to take a number, it's going to square it and return that. So I call that function like this, right? Square is the name of the function, I is an argument to that function, and then that function will have a return value, okay? It's the value that I put inside a return statement in the function, and that basically becomes the value of this expression, square parentheses I. And so if I say result equals square parentheses I, result's equal to whatever that function returns. So to write that actual function, I'm going to say it returns an integer. It's called square, it takes an integer argument, which I'm going to call x for no reason. And I'm just going to return x times x. Alright, that's our basic mechanism for passing things to functions, getting things back. You pass things to functions by listing them in the argument list, like this. You get things back by saying return, and then whatever you put after the return, that's what we call the function value. That's the integer which this function is effectively equal to. Okay, and it's like a mathematical function. It's like y equals f of x. So you do all the stuff inside here. You make a call, you do all these calculations, whatever it returns, that's the value that goes into a result. So, will it yell at me, right? Well, it yelled at me for a different reason. I said, Scooby-Doo return. Alright, so it didn't yell at me about prototyping, but in some cases it might. So, good habit, if you're going to use a function, prototype it. Alright, so I can run this and it tells me the result was 25. That was 5 squared. And I could also have done this, and that's totally legal. And I'm not going to inadvertently change the value of I by doing this. If I set I equal to 5 and I call square I, when I finish this call, I is still going to be equal to 5, even though I said integer x, and down here I changed the value of x to be x times x. So let's just put a note here. This does not change the value of I in main. And I could also have done this. Right? I can call square right here, and executes all this code, returns the value of I squared. That value takes the place of this thing, and that value will get sent to printf and will get converted to an ASCII string and printed out in place of this %d. Right, so these functions are very well behaved. We can use them more or less the way we'd think of using them intuitively in most cases. It works fine right here. In fact, I could do this, right? And this says, let's call the square function and pass it an argument of I. And since I is 5, this will be equal to 25 because we returned the argument squared. So this is 25, which means this is making a call to the function square with an argument of 25, which will square 25, gives you 625, and that's the value that will get passed to printf for the %d. right? So you can do all these things. All right, so let's go over the quiz. And this is topical to a question that I was just asked in chat. So let me bring up Canvas over here on the side. And let's hop onto our homework 5. So most people did this quiz. Again, you didn't have to do a whole lot of creative thinking. It was more of a lab exercise. So so this was looking at scanf and scanf. And if you're finding infinite loops in your input, there's a good chance you're using scanf instead of scanf. So let's look at what happens with this quiz. So the first question was to type this code into an editor and run it and enter the word hello and see what it does. So let's do that. Alright, so here's my quiz code. And let's run it. And if you put in an integer, it says, you know, success I equals 23. That's all fine. But if you run this and you type in hello, it says success I equals 0. And that's a little quirky, right? Because you're supposed to enter an integer, and I typed in hello, and it said, success, you entered the number 0. Well, I didn't. I entered the word hello. And that's not the same thing as entering 0, right? So we usually want our code to be smarter than this. We want it to be able to notice if you're supposed to enter a number, whether or not you entered a number. And not just say, you know, I don't know what number you typed in, so I was going to guess that you typed in a 0. Okay? That's what's happening here with scanf, though, because scanf, we're not checking to see if it succeeded in converting. We're taking an input string, we're asking the user to type something in, they type something in, and if it can be converted to an integer, that integer will be saved in the variable I. But if it cannot be converted to an integer, I is unchanged. Well, we have no way of knowing at this point which of those two cases happened. Maybe they did type in a 0. You know, 0 could be a totally valid input. And if they type in a 0, hey, success I equals 0. But if they type in something bizarre, success I equals 0. We can't differentiate those two cases. Okay? So this is not code that we want to do. Okay, we never want to just scan something and just run with it. Alright, so here's a better version of the code where we do what we've been talking about, which is we check the return value from scanf and make sure that it returns a 1. And if scanf succeeds in converting an integer, it will store that integer in I and it'll return a value of 1 to tell us, hey, I converted an integer. Alright, so this looks to be more promising. And so if you run this and you put in an integer, it comes back and it says, success, your integer is 5. Okay, no problem there. So the next question was run the same code but enter hello. Now what do we expect this code to do? it asks me to enter an integer. We try to scan your input as an integer, and we check the success of that. And if it failed, if it did not return a 1, we're going to say, hey, try again, go ahead and enter an integer, and we'll call scanf again. All right? But here's what happens if you run this and you type in something that's not an integer. It goes into an infinite loop. All right? So how do you get out of this? Hold down Control, press C. All right. Why is it doing this? Because scanf is combining two things in one. It's ingesting characters and it's trying to convert them. And so here's what scanf does. It waits for you to type something in and hit enter. You type in HELLO and hit enter. And so now scanf looks at that first character, which is an H. And it says, could this be part of an integer? No, it's not. So it says, I'm done with you. It returns a 0, saying I did not do any conversion. You pick up that 0, you print the error message, you go back here again, and you call scanf. What does scanf do? It looks at the first character in the input buffer, which is an H. And it says, is that part of an integer? No. It returns a 0. You pick that up, you print the error message, call scanf again. It looks at the first character in the input buffer, which is still an H. It says it's not an integer, it returns a 0, and you're stuck in an infinite loop. Scanf will not consume that H if you're saying this should be an integer. Okay, and so this is a classic problem. And if your code is throwing out, infinite loop behavior like this, see if you're using scanf instead of scanf. Okay, that would be my first thing to look at. If that's not the case, right, send me an email right after class, and we can talk about it. All right, so how do we fix this? Break your code into 2 steps: an ingest step and a parsing step. Right. So here we use fgets to read a line of text from the user, and then we use scanf to try to convert it. And if that character cannot be converted successfully, scanf will not return a 1, and we'll say try again, but now we ask the user to type in another line of text. And then we go ahead and we scan that. And so if this is non-integer, it will just keep asking you and waiting for you to type in more input, right? So splitting those 2 tasks, inputting characters and interpreting characters, splitting those up makes your life a lot easier, right? So we're never going to use scanf in this class, never, ever, ever. We're always going to use scanf, typically followed by fgets if we want to read input from the user. If we're trying to process a command line argument, we don't have to do an fgets. We're just going to use scanf. Okay, so use these things in a way that makes sense. Chat question: is there a way to clear the standard in buffer? Yeah, there's system level calls you can use for that, or you could ingest until you get to a new line. But that starts to get a little wonky, right? If you find that you're in a situation where you need to clear the input buffer, I would take a step back and see if there's a different way to do the processing you're trying to do. Doing an fgets will, in some sense clear the input buffer, but if there's nothing in the input buffer, fgets will block. It'll wait until the person types something in. And if you start down that path, there's a chance you're playing games with the user and the operating system that you may not really want to play. But yeah, there are ways to do that. All right, so that's just stuff to think about with fgets and scanf. All right, any questions about that or other stuff? No questions? Let's see, for that square function, could you really quickly go over how we would use pointers to actually change the value of I in the main function? Sure, this is getting a little ahead, but it's a good time to do this. So suppose you want to change the value of an argument. I didn't even spell my prototype correctly. There we go. So here's a different way to write this. Let's make a function that you pass an argument to, and it squares that argument for you. Okay. Alright, so before my call, I'll print out the value of I, and then after the call, I'll print out the value of I. And I'll make my function void because I'm not going to use the return value of the function. I'm just going to try to set up my function to square the argument. So this is not going to work. Okay, I is not going to change through the call. Alright, so how do we make this work? We pass the address of an integer, just like we do to scanf. We pass the address of an integer so that the square function, it can't change the address, but it can change what's stored at that address. Okay, so when I call square, I need to pass the address of my variable. I need to say this is a pointer to x. And this is going to look weird. But x is a pointer to an integer, so star x is the thing it points to. I'm going to take that, I'm going to multiply it by itself. That's going to give me the square of the argument, and then I'm going to set that, I'm going to save that at the thing that x points to. Okay, so this looks goofy. Right, but nonetheless it works. So this is pointer stuff, and we'll do this more in 222. But if you want a heads up on it, right? Star usually means a pointer to. Star in front of a variable means the thing that it points to, and ampersand in front of a variable means the address of that variable. So it's kind of the counterpose to a star. But if that doesn't make sense to you, don't worry about it, because we don't need that for a while. We will towards the end of the course, and we definitely will in 222. All right, other questions? Alright, I'll push that code over to to the server later. So the next thing I wanted to go over was I wanted to go back to talking about VI. We've only got like 3 minutes here, but let me make a quick start on it. So back to VI. Assuming you're living in command mode, which is where you should be in VI, there's better ways to delete things than just using the backspace key, right? Now, if you're in insert mode and you want to, get rid of that star, you have to space over to beyond it, and then you have to backspace to get rid of it, right? But if you know how to move around VI, and we've talked about moving around, right? I can use the W key to move a word at a time. And if I'm on top of a character I want to delete, I can just hit an X. And X deletes the character under the cursor. And if I do X with a number in front of it, like 8X, that deletes 8 characters, starting with the character under the cursor. And if I want to delete a whole bunch of characters, I could say 1000X, but it won't go down to a new line. It'll just work on the current line. On the other hand, if I want to delete everything to the end of a line, I can do a Shift D, and that deletes from the current position to the end of the line. If you go through the VI video, these are all specced out, and I think I tagged with comments on the middle of the screen what these commands are. So I'm just kind of showing you options here. So X deletes the character under the cursor. You can put a number in front of it like everything. Another good option is DW, delete word, and that deletes whatever is a word, usually a bunch of letters separated by stuff that's not letters. Right, so that can be quicker for deleting things. Shift D again deletes from the current position to the end of the line. DD will delete an entire line, so 2 lowercase d's in a row takes out a line. If I want to take out 3 lines, I can say 3DD, and I've deleted 3 lines. If I want to get rid of my whole file, I could say, 100DD, and there's not 100 lines to delete, but it will delete as many as it possibly can. And there's a U for undo, so I just undid all my changes. So we can delete more efficiently than just going into insert mode and backspacing. And DD, I don't have to be at the beginning of the line. If I'm here and I'm like, yeah, I really didn't want to do this, DD, and it takes out the whole line. All right. All right. So bring questions to class tomorrow on, even though stick is due at 8 a.m., we can still talk about it. We should still talk about it. No more ODPs until next Monday. So we're done with those for a few days. But bring questions to class. After questions, I want to go through and I want to try to wrap up a overview of VI, right? So I want to talk about working on the command line of VI and doing searches and copy and paste. All right, have a good afternoon. I will see you tomorrow.